Hi Sunshine friends! Miss Tara is so excited to do this experiment with you. This is really going to be fun. I know you're going to love it. So our job as our STEM engineers is to design a submarine from a plastic bottle that can retrieve a treasure from the bottom of water. So our treasure is going to be this silver dollar, and Miss Tara is going to put it into the water and it's going to sink to the bottom. And we are going to design a submarine that can get all the way down to the bottom to retrieve our treasure. In order to do that, we have to think about flotation. And floating is going to be the force, the balance that our object has going down and the force that the water has to keep it up. So in essence, the upward push of this water is making this float on top. So when we think about a submarine and how he has to go low, there has to be a way to make him do that. So that is what we are going to think about today. So in order to do that concept, we have to think about density. And density is just how tightly packed molecules are. And I know it's preschool, and when we talk about molecules, it seems really crazy. But if you look at this gravel that Miss Tara put into this cup, or this bottle, all of the gravel is really close together. So those molecules are really tight, and that makes it more dense, which means it's probably going to be heavier than this water bottle that Miss Tara only put a few in. So this is going to be less dense because our molecules are spread out. They're really far away from each other. So now Miss Tara is going to do our first experiment just to test our density on putting this into our water. He floats. Now Miss Tara is going to put this one into our water and see what happens. He floats, but not as much. So Miss Tara will put them both in here. So our less dense water bottle is kind of staying around the top, floating on top of our water. And then our more dense, where our molecules are a lot tighter together, is going deeper. So he's about halfway down. So that gives me an idea for our submarine. So here is our experiment. Can we build a submarine that can get to the bottom of our water and get to the treasure? So we know that we're going to have to play around a lot with the density of the gravel. So Miss Tara has this huge pile of gravel, which is every kid's dream. Trust me, big kids, little kids, it doesn't matter. It's very exciting. So all you need to do is your materials, which is going to be a bucket of water. Miss Tara found this one because it was clear so that you could see our submarine going down. You could use any bucket. And then you need a water bottle or a Gatorade bottle or a Coke bottle, whatever you've got at home. Now Miss Tara is just going to lay this on top just so you can see that he floats. All right, so our bottle floats because there's nothing in it. So the molecules are really spread out. There's only air molecules and they're really spread out. You're also going to need for your materials is your treasure, which could be pennies. Miss Tara just has a silver dollar, which I'm going to put in the bottom back into our water. So that's going to be our treasure. So it's very simple. The other thing that you might want to get for your materials is a shovel. Miss Tara couldn't find a little shovel with all this gravel. I could use my hands, but I found this little serving boat that's going to work just the same. So I can scoop it up and then I can pour it in. Okay, our experiment. Can we design a submarine that can sink to the bottom to get to our treasure? Our materials are our bucket of water, gravel, our water bottle, our money, and something to scoop into our bottle. So now the fun begins with our experiment. You guys can do this with you can do it with marbles, you could do it with Legos, you could do it with, let's see, pipe cleaners. You could try anything at home that could add weight and molecules into your cup. So now we're gonna start. And for my older learners, if you want to keep measurements, you can say 1 scoop, 2 scoops. So here's our first scoop. Miss Tara's going to scoop it in, and I'm going to put it into our water bottle. And I only filled it, I would say about 1/4. So it's about to here, if you can see it. There it is. Now I'm going to put my lid back on. And remember, we learned the more tightly compact our molecules are, the more dense and the more it's going to go down to the bottom. The looser our molecules are, they're going to float up to the top. Okay, so we've got about 1/4. We're going to put our submarine, and you can decorate your submarine. You can make it any way that you want, but just for the video, Miss Tira's just going to do it kind of quick. Okay, so it's not floating on top anymore. It's going down to right about here. So I think we have a lot more gravel that we're gonna need to add if we want it to get all the way to the bottom. So Miss Tira's gonna take it out. That was 1 scoop of gravel. Miss Tira's gonna do our 2nd scoop of gravel. And I'm gonna pour it in. And now that's gonna fill about half of our water bottle. So it definitely feels more dense. We definitely have more molecules inside. So now Miss Tira is gonna launch our 2nd test. Oh. So he was here, and now he's all the way down here. Do you guys think it's gonna take 1 more scoop of gravel, or 2 more scoops of gravel, or maybe even 3 more scoops of gravel? I hope you guys get to do this at home because it's super easy and super fun. All right, Miss Tira's gonna take the lid off, and now we're gonna do our 3rd scoop of gravel. Miss Tira's struggling to get our scoops. My paper is getting very thin. Okay, here it goes. All right, here's our 3rd scoop of gravel. So it is about 3/4 of the way full in Miss Tira's bottle. Now I'm gonna drop it into our water, and we're gonna see if he can reach the treasure. He is so close, but he's not all the way to the bottom. I don't know how well you can see it, but he is still about 2 inches from the bottom. So that was 3 scoops of gravel. So Miss Tira is gonna take him out. He is definitely sinking. So if we think about buoyancy and density, he is getting more dense and less buoyant. Okay, here's our 4th scoop. It almost fills our entire bottle, which means that we have a lot of molecules packed into this. And we are gonna drop it in, and we're gonna see what happens. It made it all the way to the bottom. So our submarine got its treasure after 4 scoops. So as you can see, we have a very full bottle filled with gravel. So our density, they're all packed in there, really, really dense. And with that, it went all the way to the bottom. So our experiment worked. So this is so fun. So I think what I'm gonna do when I go in is Miss Tira's gonna try to graph it, and I'll try to come back with a graph to show you guys, because we haven't been able to do much graphing. But it took 4 scoops for it to drop all the way to the bottom. So fun. I'll talk to you guys soon. Okay, so Miss Tira went ahead and marked our water line. So when we did our 1st scoop, our submarine dropped to this point right here, and then I just put a piece of tape. Then we added our 2nd scoop, and our submarine dropped to this point right here. Our 3rd scoop, and our submarine dropped to this point down here. And then our 4th scoop, our submarine dropped all the way to the bottom. So Miss Tira marked all of these with a little piece of tape so that we could come back and measure and then make our graph. So Miss Tira just brought out our measuring tape, and I just measured by inches. Again, we're preschool, so we could use any form of measurement we wanted. You could measure using flower petals, you could measure using your ruler, you could use dominoes, whatever you want. So I measured it, and it is 8 inches. And then Miss Tira measured each specific drop. So it dropped 2 inches and 2 inches and 2. So I measured it all the way down. It's hard for you guys to see that. So then Miss Tara made our graph, and I miss doing my graphs with you guys because we were getting so good at them. So we want to always be able to interpret and analyze our data. As little as you are, it is actually going to be pretty important, especially as you get older as a scientist. So I just put 1 scoop, 2 scoops, 3 scoops, 4 scoops. So that would be our 4 scoops of gravel. And then here at the top is our treasure. So we know that our treasure was at 8 inches depth. So our first scoop went 2 inches. Do you think that our first scoop in our first submarine try, did he reach the treasure? I don't think he did. So then we put in more. So we did 2 scoops and we got to 4 inches. Do you think that he was able to reach the treasure? That submarine was not. So we added another scoop. So our third try, we added 3 scoops and he went all the way up 6 inches. But he was 6 inches, so he was still 2 inches away from the treasure. So we added 4 scoops. In our 4th scoop, he was able to go all the way to our treasure. So it took us 4 scoops to make our treasure. You guys can make your own graphs, and I love when we graph at school, and I love how you guys can interpret and think about it, and just know Miss Tara misses you guys, and I can't wait to see you soon. I hope you guys had fun with this experiment. It's really easy, but super fun. You guys can definitely do it at home, and Mommy and Daddy can help you, and you could come up with all different ways to design your submarine. I love it. Bye.